Hey, my name's Wade Bussing. I'm an applications engineer for Allegro MicroSystems. I work in the current sensor business line. Here at PCIM, we have a few current sensor demos. I want to talk about the ACS 730 and ACS 732 and 733 1 megahertz current sensors. One of the sockets that we're trying to play in is where current transformers are playing right now. So the existing products are large and bulky. The layouts can be complicated. They don't do well in vibration tests. They don't measure down to DC frequencies. The cool thing about the 730 and the 732 is that they are an active system, so they measure down to DC frequencies. They measure up to 1 megahertz. The 732 and 733 are differential. So if you were to subject them to some sort of external stray magnetic field, like a magnet or an adjacent current trace or a motor winding, they would be immune to those magnetic fields, whereas something like a current transformer, in the presence of large enough magnetic fields, will saturate and become basically a useless item. Another great feature is the footprint. So the footprint is the same for the 732 and 733, regardless of the current range. So that sensor can measure down to 20 amps and up to 75 amps. If you were to try and have a modular system to measure down to 20 amps or up to 80 amps using a current transformer, you might have to plan for different footprints, different PCBs. If your customer at the last minute comes in and says, I have a 40 amp design, but this specific application requires a little more current, you don't actually need to respin your board for a new current transformer. You can Allegro offers many gain options for the 732, 733 device, and we definitely have a CAS or a gain option that would fit your needs. The next demo I want to show is our new Corliss product that we're developing right now. So the traditional way to measure high current in busbar applications is the use of laminated steel cores. This is an existing Allegro product here in the air gap of this core. It's a 1363, is a very mature product. We have a 70310, which is our latest core-based product, industry standard for accuracy and sensitivity drift over temperature. So the new product has 1% sensitivity error from room to hot, 25C to 150C, and has 1.2% sensitivity error down at -40. So it's extremely accurate, has low offset drift. And the product is released, data sheets on the web. You can get samples whenever you like. But moving away from that, one of the new products we're working on is the Corliss device, the 37650. So it's a GMR-based sensor. It's a differential sensor, so it's still immune to stray magnetic fields. But it has up to 20 times the sensitivity of Hall. So what that means is now we can measure much smaller magnetic signals. So we don't need that magnetic core to concentrate the field anymore. We can just measure the small fields generated by current in the bus bar. So we're really excited about this product. It's high bandwidth, 240 kilohertz. It has a dedicated overcurrent fault pin that's user programmable. It has built-in EEPROM for setting the fault thresholds. Thanks.